Hey everyone, and welcome to this explainer. Today, we're doing something really cool. We're pulling back the curtain on our modern digital lives. We're going to strip away the glossy user interfaces we see every single day to understand just how interconnected emerging technologies really are. We're talking artificial intelligence, data analytics, the Internet of Things, cloud computing, and of course, cybersecurity. It's like a giant puzzle, and we're going to see how all the pieces fit together.
Okay, let's jump right into Section 1, the explosion of digital data.
So, let's dive into this. Every single time you pick up your phone, you are leaving a massive digital data footprint. Take Instagram, for example. 70 million, that is the staggering number of photos uploaded to the platform every single day, generated by its 800 million active users. When you add in all the likes, the comments, the hashtags, it creates an absolute ocean of data.
Now, with all that data pouring in literally by the second, you've got to ask, how does this function actually work? I mean, how do you end up with a perfectly curated feed that seems to know exactly what you want to see? Well, this is where artificial intelligence steps in as the back-end powerhouse to process the whole shebang.
You see, Instagram relies on a highly sophisticated machine learning technique called word embedding. But, and here's the catch, it isn't just used for text. They deploy this AI to map hidden connections between actual accounts. By deciphering these complex relationships, the algorithm figures out how connected any two accounts are, giving us those perfectly addictive feeds.
Moving right along to Section 2. Where does data live?
So you might be wondering, where do all these millions of photos and data points actually go to be sorted? And this brilliantly illustrates the answer. It all comes down to structure. On the left, we've got SQL databases. These are highly structured, kind of like massive digital spreadsheets, with fixed rows and columns, which is perfect for traditional e-commerce. But for the dynamic, unstructured chaos of social media platforms, we rely on NoSQL databases on the right. They are entirely flexible and built specifically to handle the massive variety required for big data analytics.
All right, Section 3, the cloud computing revolution. Now, storing and processing all that unstructured data at scale requires immense infrastructure. So how do companies afford it? Imagine you're an executive. Instead of buying individual computers, massive server racks, and software licenses for every single employee, you simply rent remote servers. It's a strategic pivot that saves massive amounts of capital and, honestly, a lot of stress, allowing businesses to scale up instantly.
And that right there is the core definition of cloud computing. Utilizing internet-hosted remote servers to store, manage, and access data, completely bypassing the limits of local hardware. This incredible mobility and pay-per-use model means global businesses can access their crucial data anytime, anywhere.
Now, what's really interesting about this slide is how it breaks down cloud architecture into three distinct service layers. Down at the foundation, Infrastructure as a Service, or IaaS, provides virtual hardware specifically for network architects. Moving one step up, Platform as a Service, PaaS, gives developers the flexible environments they need. And at the very peak, Software as a Service, SaaS, delivers the finished applications directly to us, the end users.
But beyond just the services, the deployment environments vary too. We have public clouds, which are broadly accessible over the internet, while private clouds are secured exclusively for a single enterprise. The hybrid cloud model, though, is often the real sweet spot. It neatly combines the sheer scalability of a public cloud with the strict security and data sovereignty of a private one.
Which brings us to Section 4, Big Data and AI Analytics.
Okay, so now that our vast amounts of data are securely stored in the cloud, how do we actually extract any real value from it? We run it through the data lifecycle. Step 1, data creation, capturing those raw user inputs. Next is processing, to give it some structure. Then we hit the crucial step, analysis, where we extract the actual insights. Finally, we share those insights across the organization and archive the raw data for future reference.
But as this visual points out, this process isn't just a straight line to a finish line, it's a continuous loop of learning. By applying AI and data mining during the analysis phase, the insights we gain loop right back around to inform and refine exactly how we collect and process the very next batch of data.
The sheer scale of this loop is just staggering. Big data analytics deploys advanced algorithms against datasets ranging from terabytes all the way up to zettabytes. This is exactly where data science empowers executive decision-making. It quite literally cuts through an ocean of noise to find the actionable signal.
Let's move to Section 5, real-world technology applications.
Let's see how this all builds together. How does all this invisible back-end technology translate into the products we use daily? Well, it's everywhere. Spotify uses big data frameworks like Hadoop to analyze your listening habits and predict your next favorite track. Airlines rely on real-time analytics for route optimization. E-commerce giants like Amazon track behavior to hit you with hyper-targeted ads. And in healthcare, AI fuels personalized medicine, even predicting regional disease outbreaks so hospitals can proactively prep their supply chains. And this ecosystem even extends into the physical world through the Internet of Things, or IoT. Just look at this agriculture diagram. You've got smart sensors on tractors and drones constantly communicating with the cloud. They merge real-time weather data with smart algorithms to completely optimize farming, autonomously controlling things like irrigation and crop protection. It's a real game changer.
Finally, Section 6, Securing the Digital Ecosystem.
So, as everything from our music playlists to our farm tractors becomes interconnected, we face the final critical piece of the puzzle, keeping it all safe. When we talk about cloud security, we aren't just talking about software firewalls and encryption. We are talking about intense physical security. The actual data centers hosting these remote servers utilize 24/7 camera surveillance, strict biometric badge restrictions, massive hardware redundancies, and industrial power generators just to ensure your data is never compromised.
High-profile hacks have naturally made enterprises super cautious, but those breaches have actually driven intense industry standardization. So the crucial point here is that when a cloud provider holds strict certifications like HIPAA, PCI DSS, and SOC, it means they have been rigorously and independently evaluated to prove they are safely handling your highly sensitive information.
It is a vast, deeply interconnected web. As we wrap up this explainer, I want to challenge you with this thought. Look at your smartphone, look at your car, or think about your last online shopping spree. You are constantly feeding a massive, invisible digital ecosystem of AI, cloud computing, and big data. So the question isn't really whether you're participating in this data loop, but rather, who is learning the most from your digital footprint? Thank you so much for joining me, and keep exploring.